On Friday, the 13th of April 2029, a roughly 340-meter asteroid will pass Earth closer than many of our highest satellites. Its name is Apophis, and for a few hours, it will cross the sky over parts of Europe, Africa, and Asia, bright enough to be seen without a telescope. That sounds like the beginning of a disaster movie. It isn't.
Apophis will not hit Earth in 2029. In fact, current calculations show no impact risk for at least the next century. So why are space agencies preparing spacecraft to meet it? Because this flyby is not just a near miss. It is a rare chance to watch Earth's gravity perform an experiment on an asteroid in real time. To see why, start with the distance.
At its closest, Apophis will pass about 32,000 kilometers above Earth's surface. That is less than 1/10 of the distance to the Moon, and even closer than geostationary satellites, the spacecraft that appear to hover over one point on Earth. On a cosmic map, that is practically a shave. For comparison, the Moon is nearly 384,000 kilometers away from Earth. Geostationary satellites orbit at about 36,000 kilometers above Earth. So Apophis will slip inside that familiar ring of communication satellites, though it will remain far above the atmosphere and far from any chance of striking our planet.
For observers in the right places, that closeness is more than a number. Under clear, dark skies, Apophis is expected to become visible without binoculars across much of the Eastern Hemisphere. It will move across the sky quickly enough to make the encounter feel less like a distant astronomy fact and more like a visitor passing through our neighborhood. But Apophis is not a tiny speck. It is a rocky, near-Earth asteroid roughly the width of a few city blocks. If an object that size struck Earth, the consequences would be devastating on a regional scale. Which is why, when Apophis was discovered in 2004, astronomers paid very close attention.
Early observations covered only a short slice of its orbit. With limited data, the possible future paths spread out like the beam of a flashlight. For a brief time, one of those paths crossed Earth. At one point, the estimated chance of impact in 2029 reached about 2.7%. That is not a prediction that Earth was doomed. It is a measurement of uncertainty. And uncertainty shrinks when you gather better data. That distinction is crucial. Science does not begin with certainty. It begins by drawing every route the data still allows. When more observations arrive, impossible routes are removed. In Apophis's case, the frightening possibility was not ignored or wished away. It was tested, narrowed, and eliminated.
Over the following years, astronomers tracked Apophis with optical telescopes and radar. Each observation narrowed the asteroid's possible path. By 2021, radar measurements during another close approach had pinned down its orbit well enough to rule out an impact in 2029, 2036, and 2068. The danger story ended. But the science story became much more interesting.
As Apophis passes Earth, it will feel our planet's gravity much more strongly on one side than the other. That difference is called a tidal force. The expected changes are more subtle than a breakup. Earth may nudge Apophis's orbit, alter the speed or direction of its spin, and disturb loose rocks and dust on its surface. Imagine spinning a lumpy pile of rubble on a turntable, then giving the table a careful sideways tug. Most of the pile stays put, but some grains shift. A boulder may roll, a slope may settle. The whole object may end up rotating slightly differently.
Apophis may be more like that than like a solid, unchanging rock. And that matters because many asteroids are not pristine space stones. They are fractured remnants of larger bodies shaped by collisions, sunlight, rotation, and gravity over billions of years. A close flyby lets scientists test how such an object responds when a planet passes nearby. NASA's OSIRIS APEX spacecraft, formerly OSIRIS-REx, the mission that collected a sample from asteroid Bennu, is headed to Apophis after the flyby. It will study the asteroid's physical changes and even use its thrusters near the surface to stir dust, revealing material below the outer layer.
Europe is also preparing Ramses, a mission designed to rendezvous with Apophis before the encounter and observe the flyby from close range. Together with telescopes on Earth, these spacecraft could help answer questions we usually cannot ask until after a major event. Did the asteroid's surface move? Did its spin change? Is it a solid monolith, a fractured block, or a loose gravitationally held pile of debris? Those answers are not just asteroid trivia. Planetary defense depends on knowing what a threatening asteroid is actually made of.
If you needed to push an asteroid away from Earth someday, a dense solid rock and a rubble pile might react very differently.
One might move cleanly, the other might absorb energy, shed material, or behave unpredictably. Apophis gives us a rehearsal without the emergency. And it has one final twist. For most people, Earth is the thing being protected in this story, but during the 2029 encounter, Earth is also the instrument.
Our planet's gravity will bend Apophis's path and may rewrite parts of its surface history. Then scientists will compare what they knew before with what they find after. So, is Apophis a threat? No. But it is an extraordinary visitor, a city block-sized asteroid passing safely close enough for Earth itself to leave fingerprints on it. On Friday the 13th of April 2029, the asteroid will not be coming for us. It will be coming close enough for us to learn how to protect ourselves from the next one.
Thank you for watching. Please don't forget to like the video and subscribe the channel.